Hello everyone, this is the Pug Engineer, and today we are going to talk about Git. In this video, we are going to explain what Git is, then we will go through the installation and initial setup process, and after that I will demonstrate a basic workflow and how to use Git to safely track changes in your code. So, let's get started. Git is a version control system and can help a software engineer to track code changes while he's developing an application. It can both work great in a local environment with just one engineer working on an app, or in a collaborative environment where multiple engineers are working on a single project. Git provides safety by allowing engineers to write code in a non-destructive way, to build features or bug fixes and safely merge them into the production code base, or roll back in case something goes wrong. There are a lot of fancy words here, so how you can explain what Git is to someone that is not a developer? Well, I like to describe it as a safe way for multiple developers and teams to work in a single project without ruining each other's lives. And it's also a time machine that is allowing us to view the revision history and the changes that happened in our code base over time. It's amazing to retrospectively see full large-scale projects unfold in front of your eyes as we go through the revision history. Git is one of the most significant accomplishments of all times in the software engineering world, I might say. But enough of that. Let's go straight into the installation. If you have a Windows or a Linux machine, head to gitscm.org and have a look on how to install it on Windows or in your Linux distro. I'm using a Mac here, and I like installing things with Homebrew, which is a package manager for OS X. First, let's check if we have Homebrew installed. So I'm doing brew ---- version, and there's no Homebrew. So if you don't have it installed, just head to brew.sh and copy paste this command here, and it will go on and install Homebrew in your system. Okay, now it's done. Let's do a brew ---- version again, and now we can continue installing Git. So brew install Git. Okay, it finished now. So let's quickly check the Git version with Git ---- version. And that's the wrong one. That's actually the one from Apple. And in order to use the one we just installed, we have to restart the terminal. So Git ---- version, and that will give us 2.27.0, which is the correct one and the latest Git. So let's move on now to configure Git, and we need to set up our username and our email. So git config ---- user.name Milo and git config ---- global user.email pugengineer@gmail.com. And that's all you need to do to configure Git. Let's start with some basics. The first thing you will need to remember is that every project has a repository which holds the entire code base and the revision history. A repository can be local, and that means it only exists in your own personal machine. And there are also remote repositories, such as GitHub or Bitbucket. When using Git in a collaborative workflow, local changes are pushed to the remote, which later they get merged into the code base. Okay, enough of that. Let's start simple by creating a local repo first. But before that, we will need an example project. So let's create one. And I will open my code editor, and let me quickly arrange the screen here. Perfect. Let's create a new HTML file, index.html, and add some boilerplate code. Before we do anything with Git, allow me to explain the simplest Git workflow in high level. First, we need to initialize a repository. We do that in every new project. Once we have that, we are going to write some code, add the files to the staging area, and then commit the changes. Then it repeats all over again. Write code, add to staging, commit the changes. Okay, let's do that now. We have a basic HTML file here, and the first thing we need to do is initialize our Git repository for this project. And for that, we will use the git init command. So git init, and Git will tell us that it created an empty repository. The next, probably most used command is the git status. This command will display the state in our working directory as Git calls our folder with the Git repository we just created, alongside the changes in our staging area. I will explain what staging is in a moment. For now, remember that status is giving you an overview of what's going on. I will run the git status command now. Git will tell me that there is an untracked file, which is a newly created file that Git doesn't know anything about. It doesn't have any revision history. So, here, Git is using the concept of staging. We are staging the changes ready to be committed. To add a file to the staging environment, we will use the git add command. So, git add, then the file you want to stage. Git add index.html. If we do a git status now, we will see that our HTML file is added to the staging area and is ready to be committed. The next step is to commit the changes in our local repository. For that, we need to use the git commit command. In a commit, it's a good practice to describe what you are committing with this change. Other developers that will look at your code, we will be able to find out what changed without having to deep dive into the code base. So, let's do that now. Git commit, and an editor will open. And I think that's based on your OS or how you have Git configured. But in my case, it's Vim. So let's describe what we did, and it's a good practice to be descriptive and to the point on what those changes are, so other developers can easily follow your code. I will say here that we added the index.html file with some boilerplate code, and maybe write initial commit here, just to say that this is our first commit, although it's also right here. So yeah, obsolete information. And once done, save your changes and exit the editor. And that's how we are committing changes. If I do a git status again, we will see that our staging area is clean. That's because we just did a commit and there are no changes after that. So let's talk about branching. Branches in Git, you can think of them as a snapshot of your code at that specific time. We create branches to fix a bug or develop a feature, and then we merge that branch back to the master branch. The master branch is the default branch in our Git repository. But let me try give an example here. When we initialized Git a few minutes back and we committed the changes, we did that on the master branch. Let's assume for a moment that we want to develop a new feature in our app. A good workflow will be to create a branch called, let's say, awesome feature, and start writing the code there. But while we are developing that feature, a bug was discovered, and we need to fix it immediately. If we didn't have created a branch before, our code base will be in a bad state at the moment, with a half-developed feature. Fortunately, we had created a branch for that feature, and we still have our code in the master branch untouched. So, let's create another branch from the master branch called bugfix. Write the code, fix the bug, and commit the changes. What happens now is that we need to merge that code back to the master, because that's the last state we want our code to be. We want that bug to be fixed forever. Once we merge, we can go back to the new feature. Take attention now. This new feature branch does not include the bug fix we merged earlier, because the bug fix is merged on the master branch after the commit we used to create our new feature branch. We created that branch from an earlier commit here, but that shouldn't be a problem, since we will just need to complete building that feature, and then we will merge it back to the master branch. Once we merge, the code in the master branch will have the previous bug fixed we merged earlier, plus the new feature we just merged. So first, let's create a new branch. We can use the git branch command, git branch new feature, and that will create a new branch called new feature. But if we start writing code now, that will not be on a new feature branch, and that because we need to learn one more Git concept, the head. If you do a git log, you will see something called a head, which is a pointer to the branch you are on, and the last commit on that branch. Think of it as a pointer to where you are at the moment. Any changes you will do, it will be done in this place where the head is, and that can be the master branch or the new feature branch we just created. So, can you move the head around? Sure you can. This is a way to tell Git where you want to write code. You can point it to the previous commits if you need your code in an earlier state, like a time machine, or you can point it to a new branch if you want to start writing your code on that branch. Let's visualize it one more time. We created a branch before, and the head is still on the master branch. If we want to write code in our new feature branch, we need to move the head there first. And for that, we will use the git checkout command. So, doing a git checkout new feature will bring the head to the new feature branch. If we want to move back to the master branch, we can do a git checkout master. If we want to see our code in a previous commit, we can do a git checkout and then the commit hash. So let's go back in our code. We created a branch earlier and we can see that with the git branch command. Have a look here. You can see the master branch as well as our new branch which called new feature. Notice the asterisk. This is pointing where the head is. Remember, it's a pointer. Let's move it to the new branch with the git checkout command. Git checkout new feature. And let's do a git branch again. Notice where the head pointer is. It's in our new feature branch, as expected. So let's write some code here. Add a CSS folder and create a styles.css. And I will write a very simple CSS here, h1, color, red, and save the file. And let's add that to the index.html file. Alright, that's all we need to do in this branch for this example. Now, allow me to explain one more Git concept. We discussed about the head, and that is a pointer to the last commit of the branch you're on, and we are now on the new feature branch. So, what happens if we do a checkout to the master branch now? One expects that all the changes we did on the new feature branch will remain there, and we will just move to a clean state on the master branch, right? Wrong. We haven't committed any changes to the new feature branch yet, and changes that are either not staged yet or they are in the staging environment are going to move with us when we do a checkout. So let's assume that we do a git checkout master now. The code will follow us on the master, and if we do a git commit here, it will be committed to the master branch. If we do a git checkout new feature again, it will move back to the new feature branch again, ready to be staged and committed. So let's do that now. In our code, we are still on the new feature branch. Let's commit our changes, and in this case, I will use the git add command we used earlier with a -a for all files. Instead of adding the files one by one, you can use -a instead, and it will add all your modifile and untracked files in the staging environment. Then, let's commit the changes. We will use git commit, and instead of having Git to open an editor to write my commit comment, I will use the -m command, which allowing me to add a short message. So, git commit -m added a new CSS file. Careful here, massively adding files or communicating with short messages that are not descriptive is not a good development practice and not encouraged. Other engineers appreciate if you group the changes together in a way that makes sense, but I will show you all the shortcuts and it's up to you how you want to use them. So, now that we have committed our changes to our new feature branch, what happens if we check out to the master branch? Well, they will remain where they got committed. And if we check out to master, we will see the code without those changes in the new feature. And before I press the return key, have your eyes on the code. Ready? Have a look. Our new files and changes vanished. Let's go back to the new feature branch. Git checkout new feature. And here they are again. Let's recap and visualize that one more time. If your changes are not staged yet or are in the staging environment, they will follow you around if you do a checkout to a different branch. If they get committed, they will stay where they got committed. And if you check out somewhere else, you will see the state of the code as it was at that point. Our new feature is now developed. Let's now see how we can merge this branch back to the master. But let's see where we are first. Git branch? Okay, we are in a new feature branch. To merge the changes to the master branch, we need to point the head there first. So, git checkout master. That will get us back to the master branch, and we can now use the git merge command with the branch name. So, git merge new feature. With this command, we are telling Git to merge the new feature branch to where we are at the moment, which is the master. That's it. New feature is now merged back to the master branch. The next thing I would like to talk about is how we can see the difference between two commits. What files or lines of code added or removed. For that, we can use the git diff command. And in that command, we need to pass the git commit hashes that we want to compare. So first, let's find them with a git log -- one line. And those are the hashes over here. But with this way, it will not be easy to copy the hashes. So let's do a git -- no pager log -- one line. And now is way easier to copy the hashes. So let's do a git diff. And the order of the parameters matters. So we need to see the difference from this commit to this commit. And it will show the changes between the commits, which is the CSS we just added, and then the changes in the HTML file. The next part I want to talk about is how to correct mistakes. One of the great benefits of Git is that all your changes are being tracked. And in this case, if something goes wrong, you can always go back to the previous state. So let's start by deleting a file. I will go to my index.html and just delete it. Oh my, I did that by mistake. How we can get that file back? Let's do a git status to see what's going on. And it's super easy to fix, and the clue is already here in the status command. And that is the git restore command. So let's do it now. Git restore index.html. And that's it, our file is back now. But what about if you deleted multiple files? Do you have to restore them one by one? Let's try that now. So I will delete the index.html and the CSS file. You can recover multiple files at once using the same git restore command by just adding a dot instead of a specific file. So git restore dot. And all of our files are back now. We use the dot in other examples, such as git add. The dot acts as a wildcard, meaning basically all files in our working directory. Let's see another example. I'm going to add a couple of changes in the index.html file and add it to the staging area, ready to be committed. So git add index.html. So let's do a git status to see where we are. And we have a modified file, index.html. But how we can unstage a file that we accidentally added to the staging area without losing the changes? The same git restore command can be used with a parameter -- staged. So let's do this now. Git restore -- staged index.html. Let's do a git status again, and the file is back to the working directory. We have now unstaged those changes. And how about deleting the changes in the file? Git restore index.html. And the changes have been vanished. So git status, and we have no changes. Just to recap, if you want to undo the changes in a specific file, just use the git restore command and the file name. If you want to unstage the changes, just use the git restore command with -- staged as a parameter and the file name. Now, let's see how we can get back to the previous commits. I will quickly add 2 more commits here. And let's assume that we want to go back to the previous commit here. For this, we will use a new command, Git Reset. It's a powerful one and a dangerous one, but in this example, we will use only the safe approach. To go back to the previous commit, we use Git Reset -- soft head title, and the number after the title is how many commits we want to go back. Basically, it's the position. It means -1, -2, -3. So we want to go to the one before the head, and we are going to use the head title 1 in this case. Let's see what happened. And there is a command to display all the Git reference updates, such as reset and merge. And that command is git reflog. And we can see here that we did a soft reset. How about canceling that soft reset and getting back to our last commit? To move forward the position, we use the add character. So git reset head add and in curly brackets, how many positions we want to move. So let's go forward one commit. And let's do a git ref log again. And we can see the change here. We moved forward one position. And if we do a git log one line, we can see that we are back again in the last commit, the one we deleted a while ago. So this is how you can undo mistakes in Git. And all those commands are quite easy and safe to use. They are not destructive. Moving on, we have seen that commits have hashes associated with them. What about if someone asks to find in which commit a specific feature was developed? Sure, we can say E3FC9F0, right? Or use Git Tag to generate tags that will help us remember those important commits, and assume that is when version 1.0 of our software went into production. Let's call it like that. So Git Tag 1.0. You can also mark previous commits with tags. Let's do a git log --1 line. And you can see the tag we just created just right here. Now let's try to tag this commit over here and call it new feature. So git tag new feature and the hash after that. And that will create a new tag for this specific commit called new feature. We can use git tag to see the existing tags. And to delete a tag, we can use git tag -d and the tag name. And now this tag deleted. The best thing is that you can check out tags. So git checkout new feature, and we'll check out the new feature. Tags are great. They are super useful to mark significant releases and help you check out quickly when needed. The next scenario I want to explain is a very common case. Let's create a branch first and call it new amazing feature. A quick way to do this is git checkout -b new amazing feature. That's a really cool shortcut. It will create a branch and then checkout. Let's write some code here. And while that's happening, the boss come over and say, "Oh, there's an important fix I want you to handle now. But I'm working on the new amazing feature right now. I don't want to lose my ongoing work. I'm not ready to commit on the current branch yet. And if I check out back to master, the changes I already made are going to follow me. Otherwise, I have to discard them." So the case right here is we need to have a good way to leave things as they are and then move to work somewhere else. This is where Git Stash come in. Git Stash will allow us to store our current changes temporarily, to focus somewhere else, and retrieve them later in order to continue working. First, let's see the state of our working directory. We have a modified file right here. And I will save the stash now by using git stash. Git will stash our work and it will call it work in progress. Let's do a git status again. We can see now that our working directory is clean and our changes have been stashed. You can see which stashes are available with the git stash list command. And that will show the whip stash we just created. We are free to check out now, create a new branch, work on them, commit, and do whatever else we want. At any point, we can return to our new amazing feature and continue working on our stash changes. And to retrieve the stash, we do git stash apply. We will see that our working directory is including the changes we store in the stash. Finally, to delete the stash, we do a git stash drop, and that will delete our stash. And that's about stashing our work. Super useful, right? I will finish this short introduction with a tip. If you have watched my previous tutorial about iterm, you will know that there is this command alias get grep that will give you shortcuts. So for example, if you want to do a git stash clear, you don't need to write the entire thing. You can just write gstc, and let's do that. and we'll do a Git Stash clear. And that's super cool because you can, in 3 or 4 characters, you can quite write big commands here. For example, reset the origin to the current branch and so on. That's all for today. In the next video, I will show you how you can work with remote repositories in a collaborative environment. Thank you for watching. See you next time.